I'm here on August 12th, 2024, with Mike Berners-Lee, a pioneer of tracking the environmental impact of different activities, including computing. Thank you so much for doing this.
Pleasure.
Could you state your name and then, in just a couple of sentences, explain to a general public visitor your general background and what led to your interest in energy, carbon, etc.?
So I'm Mike Berners-Lee. I'm a professor at Lancaster University in the UK. I'm the author of several books, including How Bad Are Bananas? The Carbon Footprint of Everything, or actually in the in the US, it's just called The Carbon Footprint of Everything, and it's a tour of carbon footprints of everything you can think of. And I also run a business that helps organizations to deal with the climate emergency. And a lot of my work is about tracking climate impacts, trying to work out what the climate implications of everything that we think, do, and buy in our society has.
Right, and I got familiar with your work through your Guardian columns, where you were talking about the carbon cost of email, the internet, mobile phones, etc. Um, and so, can you briefly explain the current energy costs of modern large language models in comparison with older AI and data centers in general?
Okay, well, it's very hard to be entirely accurate about the numbers. I don't think anybody knows the numbers exactly. But what we can say is that the carbon footprint of the whole ICT industry is rising quickly. Um, we looked at all the academic research on this recently, about 3 years ago, and it came in at about 4% of the whole world's climate change impact. But that's rising really fast, and AI in particular, and machine learning, is pushing that dramatically. And now the world is building data centers as fast as it possibly can to expand the capacity of machine learning and and data centers. Yeah, just as fast as we can possibly do.
So the trend is clearly hockey stick sort of thing. Or
Yeah, and we've been looking at what's the limiting factor on that? And it's not human appetite. The human appetite for more of this stuff is absolutely vast. It's not the energy consumption, because by and large, the energy is, at the moment, it's cheap enough that it's not causing a constraint on the amount of AI that we're doing. The limiting factor is how fast can we physically build the kit.
So, can you briefly summarize the history of energy use in computing? I.e., was it significant before the rise of the web and the spread of data centers?
Yeah, well, the history is that back in around 1950, there was about one commercial computer in the world, in Manchester in the UK. And it was about the size of a small lecture theatre maybe, and it used a bit of electricity very inefficiently to do very simple calculations, like it could solve 40 simultaneous equations, but it would take maybe, quite a long time to do it, but a lot faster than human beings could do it with slide rules. That was the state of the ICT industry, and there really wasn't, it wasn't a significant proportion of global emissions at all. In the space of 70, 75 years, it has grown extremely quickly. It's depending on where you put the boundaries on what you include and exclude. But if you include all the machines, the building of the kit from our smartphones to our end user machines to the networks to the data centers, absolutely all of the lot, and all of that, and then the energy that's required to drive all that machinery as well, then at a best estimate, 2 or 3 years ago, it came out at maybe 4% of global emissions, but it really is rising fast now. It's a major contributor. It's a major contributor to the growth in global energy use.
And do you, if you don't, that's fine. Do you have any sort of comparative figures for, let's say, 30 years ago, 19, the early 90s, the early 2000s, what percentage it might have been?
It's very hard to get accurate tracking on this. We reviewed all the academic literature that we could find on this. There's surprisingly very little of it, actually. And we tried to make sense of what people were saying. And there's only about five research outfits that have really had a go at this. And some of them try and track a time series on it a bit. But just to say it's growing fast, it's one of the fastest growing parts of the global economy for sure, and definitely of our energy use.
And can you break down the relative energy costs of client servers and the networks used to move data among them? And I know one of your articles you talked about, you were trying to compare, or I think one of your Guardian pieces, you were trying to compare, working offline on your own personal computer versus on the net. And I guess that's sort of what I'm getting at. I mean, what is the network is also a major factor here, that which you've also written about. Anyway, so
Yeah, I can talk about it, a bit. So, again, it's very, very hard to be to be certain about to be accurate about this because the quality of the data that anybody can get hold of is so mixed. But roughly speaking, if you take a very broad definition of the whole ICT sector, so that's all digital communication. So, in the broadest sense, that's including conventional TV, okay? Because that's one of the things that we're now substituting for what most people would consider to be sort of modern ICT. It's roughly speaking, it's about a third of it is TV sets and including terrestrial transmission and so on. That's about a third of it, and then about a third of it, roughly speaking, is end user devices. That's our personal computers and our smartphones and so on. And then the rest is divided. Well, cryptocurrency is maybe 5% of the total and rising. And then networks is maybe 14%, we estimated. And data centers 2 or 3 years ago was about 10%. But that's really rising fast now. It's rising so fast that I wouldn't be surprised if it isn't already 20% of the total footprint of ICT. But in terms of a lot of computer usage or digital technology, things like sending emails and sending texts, the big deal is the end user device. So when you send a text or an email, the big deal is that maybe let's say you're doing it on your smartphone. Well, that smartphone has got a big bit of embodied energy in it and embodied emissions. And every time you use it, you wear it out a little bit, and you bring forward the time at which you're likely to decide that you want to buy a new one. And as well as that, there's the energy that you use while you're using it, and that's actually a much bigger deal than the tiny bit of energy that's required to send a little bit of information, a text or an email through the network. And then, of course, there's the other end user device of the person who receives it, and they take time looking at it. So those are by far the biggest contributors for that kind of thing. And if you do a Google search, it's a blend between the two. But to your point on machine learning, if you start using AI on your machine with your Google search, then you push up the Google search, the carbon in the Google search by something like round about a factor of 10. I mean, obviously depends on exactly what you're doing and exactly what you're searching and all the rest of it, but it's that kind of order of magnitude.
and I don't know if this might be very hard to track, but I mean, prior to generative AI in the last few years going public, Google, for instance, has been running contextual ads against your searches for more than 20 years. or roughly 20 years. The Was that also, in other words, is the newer AI much more energy intensive than the sort of quote unquote traditional machine learning that was doing ad auctions and that kind of stuff in the background?
Yeah, it is. It's much more intensive than that, and that's why the rise in it is causing such a pressure on data centers, and causing such a uh, just just a massive expansion in data center demand.
And I know you can you talk about the relative energy costs of, say, sending an email versus a text?
Well,
And go on.
they're both very small. So I wrote in my book, the carbon footprint of everything. It starts off with the smallest things you can have a carbon footprint of, and it goes up to the biggest things in the world. And the biggest entry in the book is burning the whole of the world's fossil fuel, and the the number is so ginormous we'd all just immediately kill ourselves off. But if you look at the very first entries in the book, they are what's the carbon footprint of an email and what's the carbon footprint of a text. They're absolutely tiny. So, from a carbon perspective, we can all just relax about all of that. It's just not where the carbon footprint of ICT comes from.
And so when you get generative AI to help you write the email, though, what
Yeah,
happens?
it's much easier if we use our own brains. Exactly.
So, I mean, per our own brains are what, about 60 watts for?
Yeah, and it's going to be doing something anyway. So the additional bit, because you're thinking hard about what you're going to put in your email. I mean, what's your background assumption? If you weren't tapping the text, would you be lying in a sofa like a zombie, doing nothing with your brain? In which case, maybe maybe you pushed it up by 20 watts, 30 watts. I don't know.
Sleep mode. um, and how about, is it any significant? I mean, obviously each email is small, but I mean, how about in general, composing emails or text offline on your own device versus while you're connected to, webmail, where you're constantly going back and forth to a server?
Yeah, it's just not that significant. I mean, the packages of data that you're sending are so tiny. How you attribute, I mean, there's very interesting scientific debate over what's the best way of attributing the total carbon footprint of the world's networks to the various usages that you've got. Because data streaming, for example, if you stream a video, it's a lot of data, but it's only one streaming event. Whereas if you send lots of different texts, it's lots of different small events. But so, the whole question of how best to take the carbon footprint of all the networks and share it out amongst all those different uses is a little bit contentious. But it's not very much.
So the difference between, say, using Google Docs, where you're editing on the server, versus Word on your own machine is not that significant, you're saying.
No, it's not particularly worth thinking about.
Okay. So a more uh, balanced client server model doesn't really save anything in energy, like as the web
No,
is
I mean,
considered.
there is a case for. We've been looking at things like accounting packages for companies that you could either get the work done in the cloud, or you could do it on the company's own server, so that you're not using an external network at all. And when we look at those sort of equations, what it boils down to is: Are you having to buy your own server for the company? Because if it makes a difference that you go out and buy an additional server, then it's not worth it. You should do it on the cloud. But if you've got the server anyway, then you may as well do it in house and not use the network. But it all boils down to the embodied carbon and energy in the kit and minimizing that. That's the critical factor.
Because I guess my question would be like, if the web had developed more as originally conceived, where it was more local and only occasionally connecting remotely, would some of the giant data centers never have needed to be built. But that's very speculative, obviously.
No, yeah, but it takes us into the question of what's happening to the world of ICT as it becomes more efficient. So I talked earlier about the first commercial computer, the Mark One and the Ferranti Mark One in Manchester. And it would spend, I don't know, I think it was about an hour it might take to solve 40 simultaneous equations, whereas my laptop will do that in a very small fraction of a second now, and burn through virtually no energy whatsoever. And just an amount of energy that just doesn't matter on its own. So you'd think, well, if we're getting so much more efficient, and we were transmitting stuff, we were slowly transmitting data down phone lines. I remember when I was a kid, this kind of thing. There was a school near me that had a modem, and you could dial up to the mainframe, and you could take you quite a long time to transmit a very small amount of data, all much much less efficient than it is today. So you'd think with all that efficiency, some people would assume, well, that means the carbon footprint must be so much lower than it was back then. But the trouble is that as we become more efficient, we become able to do more, and it becomes cheaper per unit of functionality that we get. So it becomes more valuable. So our desire to do more goes up, and our ability to do more goes up. And what we find is the amount more of it that we do goes up faster than the efficiency improvement. And if I think back in my career, even, say go back 10 years, I could have easily got my life's work onto, a big memory stick. If I was disciplined about cutting out the junk and the repetition and not keeping in, if I had the same approach that we used to have in filing cabinets, where you had to chuck out the junk because your filing cabinets would just explode, right? And now we don't have any of those disciplines, and we just have backups of this, that, and the other. And if we fancy it in high resolution, we just have it in high resolution. And in the way we're doing AI, the cost of AI and machine learning is still low enough that we're not having to be particularly, nobody's being particularly selective and careful and clever in how much benefit can we get from the smartest interrogation of the data. We're just kind of throwing a sledgehammer at it. And so we're just doing so much of everything that the footprint's going up and up and up. And that is the default trajectory. As we become more efficient at everything to do with every aspect of the ICT industry, and not least AI, so its ecological impacts, its energy use and its ecological impacts will just go up and up and up, unless we do something to make sure it doesn't keep going up and up and up.
Well, but I thought AI was supposed to solve climate change.
No, AI, it's not good enough to say, it's not good enough to be able to say there are some good things that can be done with AI. You have to say, you have to answer a different question, which is the net effect of AI will be positive. So you have to show that it won't be used for bad things, and you have to show that the efficiencies that it can bring to the economy will lead to reductions in carbon and other environmental impacts, and won't just be absorbed in a kind of rebound effect that just leads to a growth that outstrips the efficiency gain. And so AI just becomes the dynamics by which we put ever more burdens on the planet. And the sad truth is that right now, that is the way the dynamic is playing out. And that is why human impacts are going up and up and up. And it's because we haven't learned yet how to constrain the total impact that we have.
And I've read that they're now starting to co-locate data centers with nuclear plants to handle the energy. Do you have any?
Well, and that's just one more. And you could say, well, that's low carbon energy, maybe. But then you need to say, well, if that nuclear plant wasn't powering the data center, it could be pumping its energy into the grid, and it could be decarbonizing domestic electricity use, for example, throughout that country. So there's always an opportunity cost. It's not actually a legitimate claim for any part of the tech industry to say, oh, our energy is renewable, so it's okay, so it's zero carbon, unless you can prove that that renewable energy is properly additional. Like none of that renewable energy would exist if it wasn't for the company that's using it. And that's actually usually a very difficult claim to make stick.
Certainly not with the nuclear plant. What is the energy cost of training versus using large language models?
Okay, when it comes to looking at the energy cost of training rather than using large language models, there are some people who studied this in a lot more detail than I have, but my broad understanding of it is that it's the training that is the big deal by far, and the actual usage is much less intensive.
And at current growth rates, what are projections, if there are any, for how much large language models will add globally to the energy cost of computing above the prior baseline for growth? I mean, assuming there was some sort of curve, how much will this bump it above? And if you want to state that more simply, go for it.
Okay, so to look at the trajectory of AI and machine learning and its energy impacts and its climate impacts going forwards, it's actually quite difficult to predict, even without the explosion in AI that we've seen recently. There was a lot of academic contention over what the carbon footprint of ICT was going to be doing going forwards. So there were even some researchers, I don't believe this, but there were some researchers who were saying the carbon footprint of ICT is going to stabilize. And the reason for that is that we're going to saturate with our usage. Once everybody in the world's got a smartphone, no one's going to want any more. And once everyone's got a computer, no one's going to want any more than that. And that assumption relies on not taking account of any new kind of computing coming along. It ignores, for example, cryptocurrency coming onto the block and the Internet of Things, and critically, it ignores machine learning coming along. So I think the most credible scenarios that I've seen, and certainly what my modeling has said, is that the carbon footprint, the default trajectory for the carbon footprint of the ICT industry, is to rise steeper than the rise in global carbon emissions and global energy use generally. It will become an increasing part of our economy, an increasingly large proportion of our economy, and the recent explosion of machine learning has really just been one feature of the dynamics of growth in the ICT industry. It's been growing in different ways at different times. Smartphones came along and they caused a bit of a bump, and cryptocurrencies caused a bit of a bump, and the Internet of Things is one of the things that's causing things to grow, and now AI's come along, and that's causing things to grow quickly. But nobody really knows. And one of the huge questions, I mean, this takes us back to the where does ICT fit in the global picture? The huge question is, what are we going to do about climate change? Is there a mechanism by which the world can get on top of climate change? And it looks pretty clear that to do that, we're going to need to constrain the fossil fuel coming out of the ground. And if we constrain the fossil fuel coming out of the ground, that's going to put a constraint on total energy use. And that will put a constraint on the energy used by the ICT industry, including machine learning. It probably will keep growing by taking a bigger and bigger share of the world's energy supply, but it will be some sort of constraint that will take us off what will otherwise be probably a very steep a very steep growth curve. I've been talking to some asset managers and investors recently, and they're all asking, they're all seeing massive and sustained growth in data centers. And they're all asking, well, what are the limiting factors? What are the things that will, you know, what are the things that stop it from growing 10 times every year rather than just doubling every year or whatever? And at the moment, it's just down to how fast can we build the kit.
And are data centers getting more efficient? And is there any progress? I know you wrote 15 years ago now. I think that there was hope that some of the waste heat could be reused and things like that. But is there any progress? And
Well, data centers are getting more efficient. And yes, sometimes there's waste heat that can be used. And data centers are getting better at not having so much waste heat. And there is something to play for in where you position your data center. So you place it somewhere where the cooling requirement is a bit less? Can you place it near a sufficient water supply that you can use water as for a lot of the cooling? And can you place it near the population that's going to use it? Because for some forms of data center usage where the use of the network is very high, it's helpful to have it to the population that's going to be using it. But all these are kind of marginal gains. And the dynamics of growth, just to repeat again, are such that the default, generally speaking, is that the more efficient something gets, the greater the total impact becomes because the amount more of it that we have goes up by more than the efficiency improvement. So we need to do something to interrupt that dynamic. And that has to be in the form of some sort of constraint. And um, that takes us back to the ever recurring conclusion that we need to find a way of constraining the fossil fuel coming out of the ground. That's just, for me, that's the logic of the argument.
how significant is water use by data centers?
Um, it can be. It's good to put your data center somewhere where the use of that water, where water is sufficiently abundant that it's not a problem and you can use it as part of the cooling process. But it's generally speaking, it's not the biggest deal. The biggest deal is the construction of the data centers and the energy that they're going to use.
And what role does or can regulation play in governing energy efficiency?
Well, I'm going to come back yet again to my overarching thing because if you try to regulate the ICT's industry or any other industry in such a way that it's going to minimize its environmental impacts, including its climate impacts, it's very tricky to do it um, in a way that's sufficiently leak proof that you can head off all the ways in which that regulation can be circumvented. And in industry after industry that I look at, because I don't just look at the tech industry, what we find is that all roads come back to this central question of if you could just constrain the use of fossil fuel, then it wouldn't matter. Market forces would then place a constraint on the energy use and environmental burden of every other industry. And if one industry wanted to have more energy use, it would have to compete for it against the other industries. So the ICT sector could have more energy use, but it would be at the expense of spending less energy on building cars or running trains or flying airplanes or something. And the other thing is that under that carbon constraint, the desire for energy efficiency, the hunger for energy efficiency that the world would have, will be higher than anything we've ever known. So we would end up with rapidly advancing, much more rapidly advancing improvements in energy efficiency. And the role of that energy efficiency would no longer be to increase our burdens, it would just be to enable us to do more. So it would be a very different sort of dynamic that we'd have going on.
And how would you achieve that? Carbon credits or
Uh,
regulation? I mean, I know it's a big.
well, I think it's quite an easy answer when you look at it. I would have a carbon price, right? And we can argue about how you'd put it in place. Eventually, it needs to effectively operate at the global level, but it wouldn't need to start off at the global level. When it's not global, you'd need to have border trade adjustments between parts of the world and industries and so on that were playing the game and parts of the world that economy that weren't playing the game. And everybody says, oh, well, that's so difficult to put in place. And that's right. It's difficult to put it in place. But the good news is that when you've put it in place, it will work. And everything else will fall out of the hat. The ICT industry will no longer need to worry about what its carbon footprint is. It will just it will be worrying about where it can get its energy from, because the carbon footprint of the world will be fixed by that carbon price.
So you're
And
saying, oh, sorry, go ahead.
although it's difficult to put in place, once it's in place, everything else will fall out of the hat. We as consumers won't need to worry about what our carbon footprints are, because the price of everything will be adjusted and will be incentivized to go for the low carbon option all the time. And if we really want the thing that's the high carbon option, well, that's okay. If we want it enough, we'll have to pay a bit more for it. And the world won't suffer because it won't affect the amount of carbon that's going up into the atmosphere.
And who would set the price? That would be a tax in essence, or?
Well, the way you'd have to be able to ratchet the price such that you'd know the price was high enough because the amount of fossil fuel coming out of the ground would be low enough. And if too much fuel's coming out of the ground, you'd need to put the price up. And there are various ways of doing it. I mean, there are you could have trading schemes and so on, and there are economists who look at this in great detail. But but broadly speaking, it has to be a global carbon constraint. And it's no good, just while we're on the subject, it's no good just increasing the renewable energy capacity. Some people say we'll deal with climate change by building more renewables. Well, that's okay, but the trouble is that unless you constrain the fossil fuel, the way the dynamics of growth goes is that you end up having more renewables and more fossil fuel. And that's exactly what's going on at the moment. So the renewables today aren't actually doing the world any good. Not really, a little bit.
Right, because it's additive, you're saying.
It's
Um,
additive. We're having them as well.
People have talked about AI. Some people say it'll move to the edge, so it'll be in your phone and your vacuum and your car. Would that make any difference if you have a lot of large language models in your own devices or not?
Well, it depends how selective we are. You know, a little bit of AI can be used to, if it helps me to optimize a journey, then that's, potentially there's quite a big carbon saving can come out of that for a relatively small amount of computing power. And it's clear that there's more that can be done than, a conventional Google Maps search of, directions. There's more that could be done with more information about me and the environmental impacts and the value of my time and what I like, how I like spending my time and so on like that. There are all sorts of ways in which my journey could be optimized better than we can currently do. And up to a point, that's worth it and it's a good thing to have. And then we get into diminishing returns. And if we just start throwing unlimited computing power at absolutely every decision that's anywhere in our lives, then eventually, we'll get to the point where the whole thing becomes so energy intensive that it's not worth it.
Some people say that AI is taking away energy that's needed to mine cryptocurrency. Do you have any?
Well, My own view on. Thank you for
I'm
that.
kidding, but if you want to answer, go.
I think for me, cryptocurrency is an example of something which has a very definite environmental cost and it has no inherent value to human well-being.
And if you could create your own chatbot, what would it be like or what would it do?
I don't know. You know what? I wouldn't really want to.
And what's your personal probability of doom that AI will doom us all?
I'm afraid it's pretty gloomy. I, in fact, I don't know anybody who's thought carefully about the role of AI in the world who has a positive emotional response to it. I know people who see it as a personal opportunity for them because it feeds into their work area and it gives them exciting opportunities. Um, I know people who can talk about the efficiencies that it can provide, but I don't know anybody who has a positive emotional response to it when they've thought about it really carefully. And I think the question that I would ask is if there was anything about the trajectory of AI that we were uncomfortable with at the moment, its role in the world, its influence on human well-being, its environmental impact. If there was any form of way that, in which we wanted to tweak how it could and couldn't be, how it could and couldn't be used, the question is, what would be the mechanism by which we would put that steer on its usage, by which we might regulate it, by which we might curb any aspect of the trajectory that we weren't happy with? And I think the answer to that is it's very difficult to see that how that could be done. There's so much money to be made out of it. It's broadly speaking operating in a very free market. The businesses that stand to make the most money out of it do not want to be held back. And in an environment like that, it's very difficult to curtail anything. So if you look at climate change, for example, the broad science on climate change has been crystal clear for at least 30 years. And in that time, almost every year, we've had a big international conference to try and work out how to deal with climate change. And over those 30 years, carbon emissions have just steadily gone up and up and up. The rate at which we're putting carbon out has gone up and up and up. And if you look at the curve, it's as if we'd never had any of those conferences, right? So my challenge for AI is if there was anything at all that we were unhappy with about the trajectory of AI and its impact on human well-being, you would need to construct a process to bring about change that was dramatically more effective than the process of, for example, the climate COPs. So I think it's very, very challenging indeed. So that's why I'm afraid I'm pretty gloomy about it.
So, on a scale of 1 to 100, what number would you choose for the probability of it dooming us all?
When you say dooming us all, do you mean no humans left alive?
Oh, just apocalyptic in some form. It doesn't have to be total extinction.
Well, I think it's going to be probably a contributing factor in lots of things coming together, but I'm afraid I'm going to go 80 plus.
Okay. And to end on a cheerful note, can you share a particularly memorable experience or success story involving energy and computing?
Involving energy and computing. Well, I just want to say that if it wasn't for computing, and I'm going to be really basic here, but if it wasn't for my computer being able to sort out my handwriting and my spelling, I would not be in the job I'm in at all. I just couldn't have got off the ground. I couldn't have begun to get off the ground.
Good. Um, Great. And thank you. That's perfect. I, if you want, I mean, the one thing I wondered is you were talking about it's so hard to constrain AI. You don't think let's say that there was actually some effort to limit carbon emissions. Would that have any positive effect on AI if you could, if you forced essentially AI providers to be more efficient energy wise, or is that orthogonal?
If there was an energy constraint, it would help a lot with our ability to be selective about the deployment of AI.